So prior to working at Cloudera, which I've been now for about 2 years, I worked at Autonomy on a lot of their compliance software. So a lot of people, when I go to customer sites, they ask me about my past and how much of that can we translate onto Hadoop. So something I get asked a lot, and it's something I don't see widely adopted, but I do think it's a totally reasonable use case to start moving on to Hadoop. So I thought I would go through a little bit my thought and kind of a blueprint to how you would do this. And it is something that I actively work on as well. Okay, so I don't assume you necessarily know a whole lot about the space, so I thought I would just throw in a slide here to catch anybody up who doesn't kind of know these three use cases. So when we talk about archiving, we're really talking about long-term storage of data. It is a lot more complicated than that. A lot of people just think, hey, take data, store it somewhere like a drive and or tape and be on your way. But for a variety of reasons, and we'll talk about two of them coming up, there's a lot of other things that really have to go into consideration here, like retention of that data. How long do I keep it around? How do I control that process? Or is my archive going to be active or passive? Like, do I want to run SQL queries on top of it? Do I need to process that data? Reconciliation, keeping track of what's coming in, where it came from, keeping track of the metadata around all that, keeping track of security, making sure certain users can only access the parts of the archive they're supposed to, as well as stuff like auditing of that, keeping track of like everything that's actually done on top of the archive. So there's a lot of other things that get into play here as well. Compliance, we're going to talk about that a little bit later. But if you're like a financial institution, you're very interested in having a compliant archive, which means it should say worm storage. But in the language, they really mean NEANer, which is non-erasable and non-rewritable, which is key when you're considering using Hadoop as a storage. We'll talk about that a little bit later on. So there's two use cases that really require an archive to get going: e-discovery and supervision. E-discovery refers to the review of electronic data to assess its relevance in legal proceedings. So if you're a CLO or you work in the CLO organization, you're probably very familiar with this process. From a business standpoint, you're probably mainly interested in these first two things, ECA and legal hold. ECA refers to the process of early case assessment. That's where you'll go through your archive and try to pick out relevant data to a case that you guys are currently involved in. Legal hold then refers to preventing that data from being destroyed. And that's key. And I think in the big data world, this was one of the first things that when I moved from doing compliance software to big data, everybody kind of has the assumption that we want to keep data forever. Data has a lot of value. When you're talking about this kind of data, like electronic communication, most people want to get rid of it as fast as possible because it's really just going to bite you in the butt sometime later down the road. Somebody said something in an email they shouldn't have or did something that's kind of questionable. So this is generally information that people don't want to keep around a long time, but for supervision purposes or legal hold purposes, you are actually mandated to keep this data around for specific amounts of time. The EDRM process kind of explains how this whole thing works. I'm not going to get into detail there, but there's a lot of other things in here like TAR, which is Technology Assisted Review. That's really getting into more advanced analytics and machine learning for the e-discovery process. When we talk about supervision, we're talking about the review of electronic communication to detect really unethical conduct. So we're looking at things like money laundering, customer complaints, if you're dealing with that in your organization, to see if they're properly handled, stuff like that. So that's really based around having random sampling, risk-based policies. You can't actually supervise every message that goes on in your organization, but you need to have some kind of reasonable practice to say, hey, like these are the rules that we follow. We flag messages that hit these rules. We also have some random sampling to try to detect other things that might be of interest. And then along with this, there's a lot of stuff around auditing, analytics, and reporting, which is very key to make sure you don't get fined. And stuff like that. So these three use cases, you'll often hear of them as like an end-to-end solution by some vendors. But if you kind of look at best of breed, the best of breed e-discovery solution really doesn't tie into an archive. They require you to export your data out and then process it separately. So as an organization, you have to kind of decide what the best strategy is. And I think this is kind of where Hadoop adds a lot of value to this space. So why do we care about this? If you don't care about it, you can lose a lot of money. That's generally the main reason. A lot of organizations are just required to do this kind of thing. So e-discovery is probably something done by every large organization. The supervision definitely applies more specifically to financial services institutions. So, if you're doing kind of unethical behavior behind the scenes, SEC comes in, they ask to look at stuff. If you don't have that material, you can certainly, be looking at millions of dollars of fines. And as a result, the software in this space tends to be also kind of pricey. So I think Hadoop makes a lot of sense there as a way to reduce a lot of cost and help modernize the system when you move things over. So what are some shortcomings here? For archiving, a lot of solutions still rely on databases, and databases don't really scale up to the petabyte scale that a lot of organizations now look at. If you look at the body of email in some of the large organizations out there, they are working at petabyte scale. Many of them are working at tens of petabyte scale in terms of all the electronic communication they have in their archive. So it can certainly be daunting. On top of that, it can't handle all types of data. So if you have a database and you want to analyze video data or phone calls or something, that becomes very challenging. Inflexible deployment, everybody wants to move to the cloud. A lot of these tools aren't necessarily well suited for cloud deployments. They rely on proprietary technology. I don't think there's really any open source solutions out there in this space. And then, the end-to-end piecemeal versus siloed solutions. You kind of have to decide as an organization how much effort you want to put into the integration of all these components. So you might have an archive vendor, an e-discovery vendor, a supervision vendor. They generally are all proprietary technologies, and getting them all to work together can be super challenging. Then you can go with an end-to-end vendor, which takes the integration piece complexity away. But as a result, you're then probably going to be pay a penalty in the functionality you have access to. And then a lot of them still really don't have great encryption at rest capabilities, which is more and more a concern for companies as cybersecurity threats heighten. You don't want the petabytes of electronic communication you have stored on your servers to be hacked into and released to the public. That could be pretty damaging to your brand. For e-discovery, a lot of the best tools aren't native to the archive, like I said, so there's a lot of exporting of data that goes around. Scalability is also a concern. Generally, they're built for these solutions are built for gigabytes of data. So when you're looking at doing ECA on top of a petabyte scale archive, it can certainly raise a lot of challenges based on how the solution was architected. A lot of them don't have support for advanced media like audio, video. A lot of them don't have more advanced TAR capabilities like machine learning or advanced analytics. Or if they do, they're canned pre-built stuff, and they don't let you or your data scientists go in and really define how you want to work with your data. So they can be very limiting in how you can customize them as well. The SLAs are also very important. Often you'll hear from the legal team, we need so-and-so, messages by next week, and a lot of archives just don't function that quickly, so trying to export out gigabytes or terabytes of data in a limited time frame can be super challenging. For supervision, I think the main thing I've heard from customers is that most tools are still rule-based, meaning that you have to explicitly define what messages you want to target to supervise. So you could say, I want to look at all messages going to or from Jordan because he's a really important guy, and we just have to supervise everything he says. What they want to get into is this more machine learning advanced analytics where you're doing anomaly detection on top of your email just to pick out things that aren't similar to other things. And in that same stroke, you're hopefully going to be reducing false positives quite a bit. So the rule base ends up just picking up a lot of junk. So if I'm saying these people need to be supervised or look for these words in your emails, just a lot of junk gets picked up in that. So by moving toward more advanced analytic capabilities like machine learning, clustering your data sets and looking at outliers, you can reduce those false positives quite a bit. And then kind of the other thing is a lot of these solutions are focused on batch processing. So you'll periodically get a batch of messages, process them, and then your compliance officers go and review them. Whereas, it being 2007 and this being Spark Summit, everybody wants to do everything in real time now. Supervision tools really need to gear up and focus more on real-time streaming data. Okay. So why is Hadoop good for this? For CDH, we like to say it's fast, easy, secure, and I think all of those things apply to these use cases as well. So when we're looking at things that are fast, we've got tools like Impala, which is the fastest SQL tool on top of Hadoop. You get a lot of analytic capabilities with Spark and MLlib. Intel also has the MKL library, which allows you to speed up your machine learning algorithms even more by doing a lot of those computations down on the chip level instead of in the compute layer. So you can do a lot of these highly advanced workflows that were previously kind of impossible or couldn't be customized to the way you would like them to. They're now possible, and you can do them pretty quickly. Then you've got great real-time streaming tools like Kafka and Spark Streaming to bring in your data, and you've got then tools like Solar and Impala to search and analyze that data. Kudu makes sense as just a general store for tracking updates, and it kind of works out very well. We'll show in a couple slides as a hub to connect all your different applications together. Easy, meaning that it actually scales out to the petabytes that a lot of these archives currently exist in. We can handle all types of data, so you can bring in your unstructured data, your structured data, email, reference data could be like transactional systems for supervision purposes that we'll talk about in a little bit. But most importantly, it's a single platform for all your solutions. So regardless of how you're doing supervision, how you're doing e-discovery, how you might be doing like an end-user search application on top of this, all the data lives in Hadoop, so all the integrations work out very well, and it simplifies your stack quite a bit. I think the fact that it's open source also should hopefully matter quite a bit to anybody who has an archiving vendor now and is waiting like months or years for functionality that just never comes. Having the open source components means that you can actually get involved and take ownership of those as well. And then, Hadoop being what it is, it works perfectly well on cloud or on-premise. It's really infrastructure agnostic, so it's well suited for future workloads where you might be thinking about moving some of these applications into the cloud. And then security is also very key here. So, at CDH, we offer an end-to-end secure platform. So that covers everything from authentication, authorization to data encryption at rest, which is a pain point for a lot of archives. A lot of archives don't support data encryption at rest. And that's pretty key as well. And then, Navigator is great for things like full system auditing, lifecycle management of data. Sentry is great for role-based access control. And then there are a lot of capabilities built in around multi-tenancy and BDR as well. So BDR is pretty key for archives as well. Usually you have to have the data mirrored in 2 geographic locations. So a BDR tool could be good for things like that. Okay, so can we do this? Yes, we can. So I've broken this down kind of into 3 parts that I think make sense to discuss logically, and then I'll show you how it all kind of fits together. So the first step is ingestion. You've got data sources on the left. On the top, we're dealing with more or less like electronic communications, email, text messages, chats, stuff like that. All of those in one form or another can be journaled into your Hadoop cluster. So Apache James is an open source SMTP server. It's a great place to accept all your messages, pipe it into something like Flume or Kafka, at which point Spark Streaming will pick it up, and then Spark does all of its stuff. So what are we using Spark for? We use it for deduplication. So you can hash your messages based on various criteria and then strip out any duplicate messages. Message filtering. If you look at your journal stream, you'll notice a large portion of that is junk. So it's like users who are using their account to order things off Amazon and community forums, which you don't care about. So you can filter a bunch of those messages out. Message enrichment is pretty key. So connect to something like your Active Directory, pull out things like Bloomberg IDs to connect identity across your various data sources. So you can connect one person from your email to your mobile phone to your internet chat. All of those can be connected via those types of rules. Spark Streaming could also handle things like policy filtering and reconciliation. So on the supervision step, there's still going to be some rule-based sampling that needs to be done. So that's a good place for you to just pick out messages and start flagging them as needing to be supervised. Reconciliation is just talking about the ability to keep track of all the messages coming in, get your log from like your Exchange server and reconcile the two that we actually did receive all the messages. So Spark Summit will be filled with presentations where you'll look at a lot of code. We're not going to do that here. I did write a blog on how you do this over at the Cloudera blog. So if you're interested and you want like some real code to go play around with and start streaming in, for this example, we chose Microsoft Exchange because that's pretty much what most organizations use. So that'll get you streaming and a journal stream into your archive that you can then start working with. So once it's in there, what are you going to do with it? This looks a little complicated, but I think it's important that you have the ability to use various storage layers here. And I think this is a stumbling block for a lot of traditional archives in that they try to do everything on one storage layer, and it ends up being very complicated. So on the top, we've got something like HDFS, Isilon, or like Glacier from Amazon. And what we're going to do there is just store the full fidelity copy of the data as it lies. And we're doing that because if we ever need that data, we need to have it so that it was never changed. And that's exactly what we do there. We don't do anything else to that data. We just stick it in there and we say, there's our data. We have a retention management tool. We can define retention policies on that data to say, hey, things living in this folder live for 5 years, things in that folder live for 7 years, and then it will clean things out as they roll off their retention. Similarly, in the same space, your e-discovery zone would be able to define legal holds on that data. So it would be able to work with Solr, which we're going to use to index all the content of those messages and be able to search on it, and Kudu, which we're going to use to store all the metadata and those messages so we can do fast SQL searching on it. So our e-discovery tool can work with those, figure out what messages need to be on legal hold, and then apply those legal hold into the compliance zone. So this simplifies it quite a lot. What's also good about this, I said we talk a little bit more about our compliance use case. So this is really geared towards our compliance use case where we are required by law to actually not change that data. And this allows you to separate it out such that it's not interfering with your other storage layers at all. So I think that's pretty key. Supervision, a tool on the bottom, that's going to work with a mix of Solr and Kudu Impala for real-time searching on your data and the metadata, and also full-body searching on the content of your emails. I also threw an end-user search. Some companies like to use their archive as actually the place where users will go to search historically over their email set as well. So that's another use case that pops up here. So for Spark, what are we using Spark for here? Again, Spark is really key in this. It's the glue that holds it all together. So we're using it for things like message compaction, message parsing and indexing. So we're taking one copy of the message in Spark Streaming, we're parsing it to save relevant parts into Solr, relevant parts into Kudu, and then we save the full copy into our compliance zone. And then metadata updates would also get put back into Kudu, but you might use Spark to kind of do batch updates or real-time updates of that, and also content reindexing. So what's going to happen on these apps here on the right is that your compliance officer using your supervision tool will start to flag messages. He'll say, hey, this message isn't relevant, we don't need to worry about it, or this message is like highly important, and those updates will then get put back into Kudu and Solr. At which point you can then search on those facets as well. So it's kind of a cyclical process where reviewers are feeding information back into the system, and Spark can be leveraged to automate a lot of that. And I have not yet written a blog on this, but it's in process. It will be coming soon. I've done all the work. I just haven't actually written something that's coherent. OK, so lastly, kind of the fun stuff, the analysis and the machine learning. You saw today in that Spark structured streaming thing, kind of the Lambda architecture, merging the batch and the real-time. With Kudu, you really don't have to worry about that. Kudu is kind of built to replace those kind of architectures where I can do batch and real-time all on one storage layer. So Kudu really shines here. And we can take our electronic communications. We can take reference data. So to explain this a little bit, one of the key asks I always heard when I was working on this was, hey, you have all of my communications in one spot. All of my transactional data, like who's buying and selling stocks, so on and so forth, that lives in a different spot. What I want to do is one search over all of that data so that I can have a better sense of if there is unethical conduct going on. So imagine a search where I buy 100 stocks of something for a customer, or 1 million or whatever. I can then have a process that takes that order and says, hey, I want to search the last 7 days through your email to see, are there, give me all the emails where you mentioned this stock, so that a compliance officer could then review those and say, okay, it doesn't look like there was anything suspicious going on here, like there's no insider trading or anything. Like that is a very simple ask, but it's traditionally very challenging to pull that off. By moving into Hadoop and leveraging things like Kudu, you have the ability to have what I like to call a unified surveillance. So I can have that single pane of view into various storage layers. And you could either use Impala or you could use something like Spark SQL, depending exactly on kind of where you are in this process. You're also going to use Spark to drive a lot of your machine learning. So you are getting in a Spark streaming stream, or a stream from Spark streaming of your real-time data, and then you've got all your batch data in Kudu, so you can easily merge that together and make updates to your machine learning models. So a lot of these use cases are going to be focused on just clustering of data, anomaly detection, stuff like that. But e-discovery has also, if you look like downstream e-discovery, there's a lot of technology-assisted review use cases there that use a lot of machine learning, and Spark can be leveraged for those as well. Okay. So you put it all together, you get this, which is kind of complicated looking, but that's kind of what it would look like putting everything in the same stack. We've made this a little bit more production ready by throwing in like load balancers for your Apache James servers, and you would need probably, depending on the amount of emails going on in your organization at any one time, a non-trivial Kafka cluster to handle that workload. That's more or less what it looks like. Okay, so I'll just talk briefly about a couple obstacles, and are they obstacles or not. One is a small file problem. So you may be aware that if you are using HDFS as a storage, it doesn't like small files. Emails tend to be pretty small. Is this a problem? No, not really. We said here that we're going to use Spark for message compaction. So as messages are coming in, we'll just group them together and put them in like zip files or something and store them. So what's key about this as well is that none of my applications really run off this, so I don't need my messages in a nice format to work with in my compliance zone. They're really just there to live on a long-term basis, and then I'll delete them when I no longer need to have them. So compliance archiving, HDFS doesn't actually satisfy the neener. You can delete messages. There's no mechanism to say you can't delete this message. So that's where we introduce things like Isilon, which does actually support those kind of use cases. And I think that's another nice thing about this architecture is that I've separated out the storage component, so I can easily swap in something like Isilon to handle that compliance use case, and it doesn't affect all the analysis I'm doing elsewhere. Like I don't have to worry about, does Impala run on Isilon, which it does, but we're focusing more here on the data on the top just lives there by itself, and the rest of the system isn't really that concerned with it. Large files with Kafka. Someone had once raised this as a concern with me, so I'll throw it in there. Kafka's good with small files. It's really based on the, looking at records. if you look at the average size of an email, it tends to be very small. Attachments are what throws it over the bound. Kafka does process large messages, and if you look at the average file size across an email stream, they tend to be in like 100 kilobyte range or so. So I don't think this is really that large of a concern. You may have a file every once in a while that Kafka kind of chokes on. In those use cases, it's good to have reconciliation measures. So, having Spark able to look at messages coming in and reconcile that with your Exchange logs to say, hey, we missed a message here, and then you can manually deal with those. The thing that you're not going to get for free is all the UIs you get with your vendors. So, like, the UIs your compliance officers are using, the UIs your lawyers are using for ECA, those will not exist in the Hadoop ecosystem. So that's a good exercise for like application developers who might want to work on top of the Hadoop stack and build out your own processes that would be tailored specifically to your business. That's really the only obstacle I see in this is that if you want to move over to Hadoop, the only thing you're really losing is all those pre-built UIs for you. But there are a lot of partners in this space who could help out. So, there's tons of BI, analytic reporting, visualization companies out there who provide a lot of capabilities. I think a lot of their tools could be adapted to fit into these workspace pretty quickly. EMC or Amazon have some capabilities around compliant storage. So if you do have a purely compliance use case, you can look to those for the storage piece. There are several machine learning data science companies out there who offer some pretty advanced either libraries or UIs to enable the machine learning aspects of the system. There's a lot of ETL and ingest partners to make working with kind of stranger forms of data easier to get those into Hadoop. And then as you start building this out and you've got your smart people working on it, they'll probably want to start working with things like NLP and sentiment analysis. And there are also several partners in the Hadoop space that enable that kind of stuff as well. So I think by reaching out to the right partners and using the tools that are available in the Hadoop stack, including Spark, you're able to accomplish quite a bit of this. Okay, so that's all I have. Happy to take any questions at this time. Yes.
My question is related to slides that have like the ingestion and analysis. Using the ingestion, there was a section that was saying that there was deduplication agreement, and the analysis was said a full fidelity copy. So aren't you worried that by doing the deduplication you may lose some information that may be valuable?
No, so that's a good question, actually. So the question is, do you lose information, the deduplication that could be valuable elsewhere? How a lot of solutions handle this currently is, a lot of the deduplication has to do with like, if I send out a BCC, depending on what email system I'm using, like that might appear as two different messages. It might appear as the same message, but now one has different metadata attached to it. So usually, like the content of the message will be the same. You might have different metadata across a couple different messages that come on your stream. So you would leverage Spark to kind of figure that out to say, hey, this is the same message. The metadata is the same, and then all it would have to do there is not save the message, but update the metadata in Kudu and Solar. So you wouldn't lose any of that information in this process. Question in the back. So I'm sorry, I couldn't hear that. Talk more about the security aspects. Yeah, so behind the scenes, we're just going to leverage all the security measures that currently exist in Hadoop. So, everything's communicating via Kerberos. You're doing encryption on the wire for all of your components. You can use things like HDFS encryption or Navigator encryption to encrypt all the data at rest. And then down here we have Cloudera Navigator that audits all the behavior in the system. So all your Spark jobs are going to show up there. Your Impala queries, like anything accessing the data in the system, will bubble up into that tool. So that covers everything I think that will be required from a compliance standpoint. Sorry? Are there any weak spots in the security? I mean, I would say the weak spots are like how you're dealing with the actual hardware in your data center, which is not really a Hadoop problem. That's kind of an IT problem on the customer's behalf. But making sure you're following international standards for all of that, that tends to be something that's very heavily looked at in the compliance area. And I think that's something to consider if you're moving these into the cloud as well. Like, does your cloud provider provide those same security measures that you would get if you did things on premise? Okay. Any other questions? Do we have time? Are we over, under? We're good? We're done. We're done. Okay. Well, thanks everybody for the talk. I'll be at the Cloudera booth this afternoon. If you have more questions or you want to talk a little bit more about this, I'd be happy to chat about it. Thank you.